Hi all. Today I'm going to take a seminar about the rise of edge computing, the future beyond the cloud. And first of all, uh, let me start with a quick question. Have you ever spoken to an Alexa or Google Assistant and noticed even a small delay before it responds? The delay is often because your command has to go all the way to the cloud and back. But imagine if your device could understand and process and respond instantly without even connecting to the cloud. And that's exactly what edge computing promises. So today we will explore what edge computing is and why it's needed and how it works and real world use cases and some super cool tech updates including a rideable animal like robot. And what is edge computing? To keep it simple, edge computing means processing data closer to the source where it's generated, like your phone, smartwatch, or even a robot. Nowadays, most of the high-end smartphones have the on-device AI that can do the AI task in itself. So it doesn't need a communication with the service. In traditional cloud computing, data goes from the device to a remote cloud server and then back. This causes a latency. But in edge computing, the data is processed locally or nearby, so it's faster, more secure, and doesn't depend on entirely on the internet speed. And why do we need edge computing? Now, why is the edge computing is becoming such a big deal? Like, let's take a few practical examples. Like self-driving cars, they can't wait for data to travel to the cloud and back. They need to make real-time decisions like braking or changing lanes in milliseconds. That's only possible with edge processing. And in smart factories, machines analyze sensor data in real time to detect the overheating or breakdowns. And in the gaming and AR, when you move your phone, that instantly reacts. Cloud delays can ruin the experience, but makes it smooth. And in healthcare sector, a heart rate monitor or wearable needs to alert you immediately, not after sending data to the cloud at that moment itself. Edge computing helps in faster response times, less network dependency, improved data privacy, and reduced bandwidth usage. So, how does the edge computing work? The key idea is to move the computation power to the edge. The edge means the closer to the devices. You will often hear terms like edge devices like smartphones, sensors, CCTV cameras, smartwatches, etc. like that. Also, the handheld devices, gamepads. Most of the things can call that edge devices. Um, but there are other things like edge gateways, devices that collect and process data locally. They are not a whole device; they are just a gateways. And there are other things called edge servers. It's like a what to say, many servers at a local site, like inside a smart factory. Uh, for an example, I can say like uh, the Google Home, right? Google Nest and Google Home. So that thing is controlling the every home appliances. So just like that, it is like a mini server at our home, or just a small thing that controls the data or processes locally. That can be the edge servers, and companies like Amazon with AWS Greengrass and Microsoft with Azure IoT Edge are investing heavily in making edge computing more accessible to the developers. And real world use cases would be, let me quickly walk you through some exciting use cases. Like as I told before, the smart homes devices like doorbells, cameras detect motion and send alerts instantly. This processed locally by those reading those sensors. So that's a use case. And also in the healthcare, smart pills for wearable monitor and alert patients in real time. Actually, I don't know what smart pills is. I have to research on that. And the smart cities, the traffic lights are just based on the real-time traffic conditions. I think that's really helpful. If there's less traffic, then there will be that green light will be on the most of the time. In factories, machinery checks itself and alerts engineers before failing. That is also very helpful. And in gaming, low latency streaming and faster inputs make the AR and VR smoother with the edge devices. And here's where it gets where even more fantastic. Like there's a latest tech. I think it's called a rideable animal robot. Recently, a Japanese robotics company called something called Subame Industries introduced a very big, massive four-leg robot named Arcax, and it's shaped like a giant animal or a mech suit. But here's the crazy part: you can actually sit inside and ride it. This robot has a cockpit like a small car. It's about 4.5 meters tall and weighs over 3 tons. And it works like a mechanical animal. It can transform between the walking and driving modes. But what makes it special is it's powered using the edge computing. All the motion control, real-time balancing, system decisions are handled by the processors embedded inside the robots itself without relying on cloud service. This shows how edge computing is enabling the futuristic robots, making machines smarter, faster, and more independent. Imagine a future where robots, drones, and vehicles all think and act instantly without waiting for the remote servers. That's the future of edge computing. Edge computing is building. So I would just give a small difference between these: the edge versus cloud versus fog. Cloud computing is centralized servers far away. Edge computing is devices process data locally. And fog computing is something in between, like edge devices connect to a nearby fog layer before the cloud. So there are some challenges facing, and of course, it's because of course no technology is perfect. Some challenges would be the security risk, like more devices, more entry point for attacks. So that's a vulnerability, and cost of edge infrastructure. For these things to work, it should be high-end devices. We can only see that in high-end devices because that is very costly. All these sensors and real-time, it the components will be at very high cost, and the device management and updates. It is a very like if it's relying on server, we can update it instantly. But if it's uh, used in locally, then for correcting something, we have to call each device and repair that. So that's a main problem. So to wrap it up, edge computing is not just a trend; it's becoming the new standard for responsive intelligent tech. It helps with speed, privacy, efficiency, and sustainability. And whether it's your smart speaker or a self-driving car or futuristic rideable robot like Arcax, edge computing is quite powering it all. So next time you see a smart device, react instantly and remember it. Probably use edge computing to do it. So that's all about today's tech seminar. Thank you.